So for our next type of question for function, we have our quadratic equation and we are given a limit. X is more than or equal to -2 and x is less than or equal to 2. So we're gonna put this down in our GC. So we're gonna put this whole thing down into our graphic calculator to sketch the graph. We will get something like this. So we will be getting this. So you can see there's a curve, a slight curve, then it goes all the way up. So here you get a minimum point, and we know that this is -2 and here it will be 2. Okay, now the next thing is to use our GC, find the minimum point. We get -1 and -5. So in order to show that whether this equation within this limit is a 1-1 function or not, all we need to use is a very simple horizontal line test. So we can imagine that now we have y equal to k. You can see that if I draw a line here, it cuts the graph at 2 points, right? But if I draw the line here, it cuts the line at 1 point. So since y equal to k cuts the line at 2 points or more than once, this is not a 1-1 function. So we just have to write down a very simple statement in this manner. Since horizontal line y equal to k, where k are all real numbers for the range of this function, cuts fx more than once. This means that this quadratic equation x squared plus 2x minus 4 is not 1-1 function. So this means that f, or this function, does not have an inverse within this range from -2 to 2. But it does have a 1-1 from somewhere. And the smallest number it will have, if I draw a straight line like this, you can see that it cuts at -1. And if I increase from -1, you can see that it cuts at 1 point. So this means that if I were to erase this part, we get a 1-1 function. And the smallest value for that is x is equal to -1. Okay, sometimes the question will write as h. So h is equal to -1 for f inverse to exist. Okay, now we're going to go into how to find the equation for our f inverse. Alright, for our inverse f. Now we're going to let y be x squared plus 2x minus 4. Copy down the equation, and then now you need to know that our limit is from -1 all the way to 2. So this is our limit. Okay, so we have this as our limit, and now what we need to do is to flip all the y and x. We're going to replace it with x, and so y will become x, x will become y. We're going to replace it because we are finding the inverse. And then our next step to do is to shift all my y to the other side and all my x on one side of the equation. So I'll be getting this. And the next step to do is to complete the square for our y. So you'll be getting y plus 1 square x plus 4 plus 1. And then we're going to make y the subject. And you're going to get something like this. Plus minus x plus 5. Okay, now the question is whether the inverse is a plus root or a negative root. So in order to know which is the one, all you need to do is to press in the GC for each of them to see which one is our inverse. You know very clearly that this we have is not the inverse. So the other one that give you the line, that will be the inverse. And it's good to plot it in the GC at this time, because you can go and find, or probably the next question what we will be doing is sketching the graph. So it's good to find the graph first and get all the coordinates. Okay, but I'm going to show you how to find the limits and the coordinates now. So if you realize that for the f inverse, it will be -1 plus root x plus 5. Okay, so what we need to do is we want to write down this whole equation with our domain, so you can get the full marks. But what we are missing here is our domain, so we got to find this domain. So we know that our restricted df is from -1 to 2. Okay, probably this one is a bracket. Okay, I'm gonna change a little bit on this. So we want this to be less than 2. Okay, so once we get this, on a side note, what we have is that for our domain of f, it will be equal to our range for the inverse, and for our domain of our inverse, it will be equal to our range of f. Okay, so this is the thing that you need to take note of. So we have our restricted df, and this means that this is also our range for the inverse. So we got these 2 points down here. Now, the next thing to do is to find the range of RF. So I'm going to use this blue to represent. So what I'm going to do is I'm going to let x equal -1. I'm going to substitute into my function, and I will be getting -5. And then after that, I'm going to sub in x equal to 2. So I'm going to sub in my limits into our function, and you get 4. Okay, so this means that our range for RF is going to be -5 and 4. It also means that for our domain f, it's going to be domain f inverse is going to be -5 to 4. So all we need to write here for our domain of f inverse will be -5 to 4. Once you have that, that's the whole equation for our f inverse with our domain. So once we get all the limits, we are good to go to plot the graph. And now we're going to sketch the graph. So to do that, I'm going to draw my axis, my x and y axis. And we already know that for our function f, it looks like this. It starts from -1 all the way to -2. So we have here to be -1, and at this point it will be 2. And we look at our range, what have we found? We found that it's -5 and 4. So we're going to have this to be -5 and then this to be 4. So we have found our f function for our fx. And now we're going to sketch for our f inverse. So if you're going to plot it in a GC, you're going to see that you have something like this. Okay, so this point and this point, we got to write down the limiter. So for this, we found that for our domain, this will be from -5, and then here it will be 4. And for our range, we found that is -1 and 2. So this will be -1 and this will be 2. You can see how these 2 and 4 and 4 and 2, how they flip. And this -5, -1, and this -1, -5, how they flip. So if you find the fx, if you found the fx limits, you can actually just flip to find our f inverse, right? So once we get this, the last thing to do is to take note that here, okay, this will be cutting at 0, is our y equal to x. So I'm going to write it here, y equal to x. Okay, so for every function, function and function inverse, they always intersect when they meet at y equal to x. Okay, so the next part, what we're going to find is the point of intersection. So what we're going to do, we can just use the function, not the function inverse. You can use the function inverse, it doesn't really matter, but since the question gives us the function, we can use function. So I'm going to write it here. We can use our function, which is x squared plus 2x minus 4 equal to our x. We're going to solve simultaneously for this, and you'll be getting x is equal to minus 1 plus root 17 over 2. And you can see how I reject the one with negative, because the point of intersection, the x will give us a positive value. So this is how you find the point of intersection for our function and function inverse, by using y equal to x.